Now the plan was to finish chapter 17 before what would have been the Easter break. So here is some examples from the end of chapter 17, which they call the multi-stage problems. First thing to say would be multi-stage problems are simply just about applying the rules we know appropriately more than once to generate equations. So sometimes we've got two sets of examples typically. Sometimes the acceleration will remain constant throughout. So A, the acceleration will link the equations we form. And other times the acceleration might change in the first to the second to the third to the fourth time intervals. So often we work in the first time interval to find how that finished in order to start the work on the second, which means we can then go on to work on the third, and so on and so forth. So it's good. There'll be some often forming and solving simultaneous equations. What remains true though is the Suvat equations, which are on the formula sheet, and you have to be careful with notation and signs, because remember in the Suvat equations displacement and velocity are vector quantities. So I'm going to go through I think it's an worked example and one of the questions. So this is worked example 17.10. You may want to read that now. It's the one which has the three cameras positioned on a straight road. Notice what they give you is information between A and B, between B and C, and they give you the time intervals for A to B and for between B and C. So what does the question ask us to find? It wants us to find U. So what can we do with that information then? Well, between A and B, we have the displacement, we have the time, and we're told that the initial speed is U, and we're told the acceleration stays constant throughout the whole thing. Right. Between B and C, we know the displacement's 30, we know the time is 2.3, but the initial speed here won't be the same as the initial speed at A, will it? So the initial speed at B will be this V, and the acceleration is still A. Well, if you look at what we've actually got two sets of information, but with 1, 2, 3 variables. And usually, if we want to solve simultaneous equations, we're looking for two equations with only two variables. So what do we do? If you look at the information for between A and C, a total displacement of 80, a total time of 5.4, and now because we're going from A to C, the initial velocity is U, the same as in between A and B, and it's the same acceleration. So what can you do now? If you look at that, we've got STU in both of them, because we're wanting to find U, and the question said A was constant, so there's the clue. SU A and T, S equals UT plus half AT squared. This information generates a pair of simultaneous equations, which boringly now on our exam you can use your calculator for, unless, and we'll go on more about the wording when you're back in school, it says show you're working or fully justify your answer, etc, etc. And anyway, you get these two answers, that U is 18. They didn't ask for the acceleration, but it is worth noting if you have done it on your calculator, you get a negative number because of course it was decelerating. Okay, worked example 7.10, really classic example of acceleration stays the same across both time intervals. So in this case, it's A and U that are the variables linking the two sets of information. Okay, the other thing I've done is from 17D question 8. If you want to pause the video to read this one, you'll now have read that this is two time intervals and the acceleration has changed in the two time intervals. So where should we start? Hopefully you know a good place to start might be a diagram, And in my diagram, I've nicely shown that for the first 25 meters, it's that acceleration. And for the next part of the journey, it's that. To make life easier for myself, I've also called these points A, B, and C. It has an initial velocity. Well, actually, the initial velocity is 0. When it gets up to that point and the acceleration changes, we have a V, which is the velocity at the end of the first interval, and it'll be the velocity at the beginning of the next interval. So what do we do? Well, from A to B, we know U, we know A, we know S. Right, if we want to find the height it finally gets to, it would seem sensible to me to find the velocity at the end of that interval. V squared is U squared plus 2AS, and we get this result. Now, the reason I haven't converted that into an answer is because often, if we're going to put that back into V squared is U squared plus 2AS again, we find we don't have to work it out. If you want to work it out, you can do that because you can always use the answer button. So now from B to C, that value we've just found is now the initial velocity in the next interval. We want to find the greatest height the rocket gets to, which is where it stops. Now the motor's off, the acceleration is just G, downwards. Note the change of sign there. And we want to find S. V squared is U squared plus 2AS again. S is 13.4, but the maximum height reached is that plus that. And we can talk about the end, about whether we think 3 sig fig or 2 sig fig is appropriate. Okay, but whatever you do, you should try and be consistent. That's the first part of the question. Speed when it returns to the ground, well, it falls from C to A. At the very top, it was stationary. It's equivalent to being dropped from that height, isn't it? Now, I'm going to now say, since it's traveling downwards, so since it's traveling 38.4 downwards, I'm going to call A and S both positive because they're both in the same direction now. And we want to find V. V squared is U squared plus 2AS again, which gives V squared is 753, which gives V as 27 or 27.4. And just be consistent, I picked 3 sig fig for the first one because we had some values, 2 of the values were to 3 sig fig. One of them was 2 sig fig. Either's acceptable here, just be appropriate. Right, if you work through 17's D now, there are lots of good questions in that. And then over what would have been the Easter break, you can have a look at the mixed practice 17. On the email, I've said which ones to submit. Okay then, important, so I'm going to look into the camera now. Don't just send me a list of answers you could have copied from the book, okay? I want to see you working. In fact, don't send me, if it's only going to be the answers, don't send me anything. Send me some working. I am reading it and I am putting comments on. Okay then.